Greetings, this is Chemistry with Nav. In this video we're going to take a look at titration calculations. Now titration is an analytical method that's used to find the exact point that an acid and an alkali neutralize. So in theory the only thing left in your flask should be a salt water solution and maybe some indicator. So one of the most important things that we're going to have to consider is the calculation of concentration, and that concentration is equal to moles over volume, and however that may rearrange. So the units of concentration are moles per decimeter cubed, or that could also be written as moles over decimeter cubed. So just have a look at how the units and the actual equation there are incredibly similar. So if you ever forget a formula for something like C equals N over V, just have a look at the units and they might give you a hand. So the best way to do this is by actually trying a couple of questions. So in this first question, 25 cm cubed of 1 mole per decimeter cubed ethanoic acid was neutralized by 18.7 cm cubed of sodium hydroxide of unknown concentration. Find the concentration of NaOH. So the first thing to do to make this easy is to write out a chemical equation for it. So ethanoic acid starts ETH, therefore it's got 2 carbons, so it's going to be CH3 COOH, being a carboxylic acid, with sodium hydroxide, and a nice simple 1-to-1 reaction, and that gives us a salt, which is CH3 COONA, called sodium ethanoate, and water. Now, having written that in, I'm going to put in any other information that I have, such as volume, concentration, and then moles. So the question tells me that I have 25 cm cubed of the ethanoic acid, that the concentration of it is 1.0, and that the sodium hydroxide volume was 18.7 cm cubed. We're trying to find the concentration of the sodium hydroxide, so that's my target there. So the way that I'm going to calculate this is, as I have done in other mole calculations, come down to moles. So the calculation is 25 over 1000 times 1, which is quite conveniently 0.025. I have to go across, but I apply a mole ratio. In this case it's nice 1-to-1. So that gives me 0.025 moles of sodium hydroxide as well. And now we just need to go up to find the concentration. And we said that concentration was moles over volume. That's 0.025 over the volume, which is 18.7 over 1000, giving a concentration of 1.34 moldium minus 3. Don't forget to give your answers to three significant figures unless you are told to do something different in a question. Now, is that a sensible question? Is that a sensible answer even? Well, the 25 cm cubed was at 1 mole per decimeter cubed, so if that's being neutralized in a 1-to-1 reaction by 18.7, we would expect it to be of a higher concentration. So yes, 1.34 is a sensible answer. So a nice simple mole calculation there. Here's a second example, and this time we have 15 cm cubed of sulfuric acid, which is requiring 19.6 cm cubed of 0.75 mole per decimeter cubed potassium hydroxide for neutralization. Find the concentration of the sulfuric acid. I'm going to do it in exactly the same way. So sulfuric acid is H2SO4, and potassium hydroxide, well, potassium is in group 1, so it's going to be K+, and the hydroxide is OH-, so it's just KOH. That reacts together, and we're going to make potassium sulfate as the salt, but the SO4 ion, sulfate ion, is a 2- ion, so it's going to need 2 of those potassiums in order to balance it for its formula. And we make water as the other product, which means that we need 2 of the KOH and 2 of the water. Same sort of structure again, so I'm going to have volume, going to have concentration, I'm going to come down to moles. And the question tells us that there is 15 cm cubed of the sulfuric acid, that there is 19.6 of the KOH, and that's at 0.75 mole DM minus 3. So my target is the concentration of sulfuric acid. So here goes. We only have one place to start. It's the place where we have two details about one of the substances. So the number of moles is going to be concentration times volume, so that's 0.75 times 19.6 over 1000, and that comes to 0.0147. Now this time there is a 2-to-1 ratio from the KOH to the H2SO4. So following the arrow from the start to the finish, it's going from 2 portions down to 1. So I'm going to divide that number by 2. And that gives me 0.00735. But now I go back up in order to calculate my concentration, where concentration is moles over volume, so 0.00735, and the volume is 15 over 1000. Gives me a concentration of 0.49 mole DM minus 3. Again, is that sensible? Well, because of that 2-to-1 ratio, we do expect to need about half as much sulfuric acid, but there's a similar amount, therefore the concentration should be quite a lot lower. So that's titration calculations. Do make sure that you look out for any diprotic acids, so that's H2SO4, or perhaps dibasic bases, so things like barium hydroxide, which is BaOH2. Those are the main things to look out for.